Hello, everybody. Welcome to AP Environmental Science for Monday, April 13th, maybe? Time has no meaning anymore. I hope that you are all healthy and well and that you are getting outside and seeing nature and watching the flowers bloom. It's beautiful. It's beautiful spring. I hope that you are staying safe, that you are washing your hands, that you are, as I just touched my face, not touching your face. So plan for the day. We are going to have this lecture, which should be pretty short. There are going to be some additional videos linked on Haiku that are optional to watch. Like you can watch them if you want to. You can skip them if you want to. I recommend watching a couple of them just to see what they're about, but I understand that e-learning is a lot. So this one is mandatory. The rest of them are going to be optional. After this, I'm going to have you go to the Drawdown website, which I'll talk about in a little bit, and then and research two of the drawdown techniques that it's proposing. Any two of your choice, only two. And then the last thing, I am going to have you write an FRQ today on the College Board website, so we can start getting into that really good practice. AP exam is coming up. I know that you guys are going to do well. Remember, 2 FRQs. Other announcements. Office hours every day, 1 to 2, Monday through Thursday. I would love to see you, even just to say hi. You don't have to ask questions if you don't want to. Email me if you're running into any issues, if you have any questions. When I know more about the AP exam, I will share it with you. I think that's it, so let's get started. Okay. So we talked about how do we know the climate is changing and how do we know it's us? Now we're going to talk about what kind of impacts are we going to see. Trying to get me somewhere that will be out of the way. What kind of impacts are we going to see and what can we do about it? So impacts and mitigation. So what are major impacts? What can we do? So big thing to remember with climate change impacts is that there will be winners and losers for climate change. So if you take a minute to think about what this means, it means some people, everybody will see impacts, right? But impacts will be disproportionate. And so areas that are possibly populations that are more vulnerable just in day-to-day without climate change will continue to be more vulnerable as climate change impacts occur. This can vary from food insecurity to housing security to where are we going to see the most people displaced. Okay, so a lot of different factors into winners and losers in climate change. Also, you'll see some areas that were maybe not great for farming might become better for farming. So not everyone will be impacted the same way, and not everyone will be impacted with the same severity. And so it's really our job to try to lessen those impacts, especially for the most impacted populations. Okay, so what are some of these impacts? We are going to continue to see rising temperatures. With that, you can see extreme heat and environmental degradation. And this you can feel free to pause and look at because there's a lot of information on this slide. We will see more extreme weather. So this is especially true with hurricane seasons and droughts. Okay, so seeing more intense hurricanes or more frequent hurricanes, seeing more intense or more frequent droughts. This also can lead to degraded living conditions and social inequities. So think about maybe people that don't have air conditioning will be more impacted by more extreme heat events. And another thing is it changes vector ecology. So vector is something that spreads a disease or a virus. So examples would be anything that's spread by mosquitoes. When you have when the mosquitoes have a wider range because it's warmer in more places, you'll see more of those mosquito-borne illnesses. And that is to do with heat and humidity. Next one, rising sea levels. So we can see with rising sea levels, water quality impacts such as cholera, harmful algal blooms. We can also see some increasing air pollution and allergens. And then increasing carbon dioxide levels. So this can lead to water and food supply impacts and more severe weather, which I think I would put over here, but okay. So just some impacts. This is a 10-minute video from SciShow. It is about 8 years old, but it is still pretty good about climate change impacts. It'll be linked on Haiku. IPCC is the Intergovernmental Panel on Climate Change, and they have listed many, many major impacts. We're just going to talk about a few. Number one, climate change is going to continue through the century and beyond. So a lot of the projections you see are for 2100. It will continue throughout past 2100. Temperatures are going to continue to rise, so it's going to continue to get warmer. Frost-free season and growing seasons will lengthen. Changes in precipitation patterns, so drought in different places, more rain in different places. Indiana is actually poised to see more like heavier spring rains, which is not good for planting. More droughts and heat waves, kind of ties in with number 4. Hurricanes becoming stronger and more intense. Sea level rise of 1 to 4 feet by 2100, and an ice-free Arctic, which is a whole thing. Okay, so a spotlight of these major impacts. This is going to be, or I'm going to talk a little bit about growing seasons and growing zones. So this is the 2012 plant hardiness map, and this is still being used. Okay, it was updated in 2012 with different growing zones than what had previously been on the map. This tells you like when you can plant things. So on the back of a seed packet, it will say if you live in zone, where are we, 5B, you can plant this, like your date of last frost is probably around this time. Okay, so that's what this is for, but it kind of tells you about temperature. So this is from 2012. This is the same map in 1990, I believe. This one is really hard to read, so I have a better one to read, but you can tell, like, this looks slightly different if we look at Indiana than that, so something's going on here. So this is from arborday.org, and this shows how the map has changed. So areas with this light red went up 1. So if we were in zone 5, which we were, we would then move into zone 6, or 5A would move into 5B. The blue means that the zones are decreasing, so maybe from 5 to 4. That has to do a lot with elevation, is why those zones went down. But as you can see, a lot of areas in the United States have changed growing zones because temperature averages have risen over the past 60 years. Here's a picture of the 1990 map from Arbor Day versus the 2015 map, which is when Arbor Day did these updates. So you can see those growing zones. This one really shows those shifts. Okay, so as these growing zones change, it's not just when you can plant stuff, right? It's also changing ranges of tolerance and locations for ideal climates for animals and plants. So trees and other plants that may have once thrived in Alabama may soon feel more at home in Indiana. So we might see things that were once really thriving here not thrive here as much, and some warmer weather plants thrive better. As our growing zones change, the latitudes of the breadbaskets may too change. So we talked a little bit about places that were once really good for agriculture may not be as good going forward. Okay, another major impact, ocean acidification. This video I think is already up on Haiku. So what happens is you have atmospheric carbon dioxide. It dissolves in water and becomes carbonic acid. And that carbonic acid has a hydrogen ion that will attach to carbonate ions and dissolve them. This is bad for things with shells. So here we have some kind of shelled creature, and this is as it's been exposed to higher pH or lower pH water. It's also bad for corals that have like a carbonate skeleton essentially. So anything that has a basic or a carbonate skeleton, as the pH in the oceans drop, they're going to have a bad time. Next one, sea level rise. So there's going to be a map up on Haiku that you can like go and play because it's really hard to see at like a national scale what sea level rise looks like. So you got to like look at municipalities and look at like smaller areas. So like look at New York City is what I'm going to tell you. We're expecting 0.5 meter to 2.5 meters rise by 2100 or 1 to 4 feet. And the rise will vary based on the location. So some areas will see more sea level rise, some will see less. We are seeing some sunny day flooding. So this is from Miami and this is from Venice. And what you're seeing is extreme high tides are now causing flooding in these cities that sit close to sea level, not because it has rained a lot, but because the tides are becoming higher. Okay, so what can we do? Mitigation. Mitigation means to make less. And when we speak of mitigation in terms of climate change, we're trying to make the impacts that are being projected less impactful or less bad. So we want to see 1 meter of sea level rise, not 4, or 1 foot, not 4 feet of sea level rise. What are some ways in which we could mitigate climate change? We can reduce CO2 emissions, oh no, and increase carbon sinks. So this is a scenario, this is a bunch of scenarios. This is a model based on like business as usual emissions, slightly lower emissions, and like if we really try to reduce emissions. So depending on how our behavior changes, we can change how much CO2 will pump into the atmosphere. Increasing carbon sinks just means increasing forests and other things that sequester carbon. Okay, these 2 videos up on Haiku about climate change mitigation that have to do with farming, which is kind of cool. Adaptation. So mitigation means make less. Adaptation means to build resiliency in the face of climate change. So it means we're going to like catch the ball and we are going to adjust and make sure that we continue to have the best lives possible. So adaptations that we can make for climate change, we can develop drought-resistant crops. We can make cities more resilient. There's a video about climate resilient cities that'll be on Haiku. There are a bunch of different adaptations for climate change. Another adaptation would be like building things to prevent flooding. Okay. So, resiliency, sorry. Resiliency is the capacity to recover quickly from difficulties or toughness. So, we want to make sure that we are resilient, that we can bounce back. So, examples of adaptation and mitigation, and some of these things can be both, right? So adaptation, you can change land use, relocation, so you can say, hey, don't live on barrier islands anymore, maybe move inland a little bit. Emergency and business continuity planning, upgrades or hardening of building and infrastructure, residential programs promoting adaptation, and health programs. Mitigation is more of planning more carbon sinks, capture and use of landfill gas, using renewable energy, making things more efficient, things that we talked all about in the energy unit. So some of these things are both. So green infrastructure can be adaptation and mitigation at the same time. Okay, your turn. So what I want you to do is go to drawdown.org, and this is based on a book. And I'm going to try to get to drawdown.org really quick. It looks like this. I want you to go research 2 solutions that they propose. They have a bunch of solutions. And like here, bioplastics. It'll come up and it'll tell you all of this information about it. On the Google form, answer the questions, what is the solution? What's the cost or benefit? What are the CO2 impacts? And do you think we should invest in this? Why or why not? Okay. That's all I got for you today. Email me if you have questions. Stay well. Do the FRQ at the end of this too. Bye.